Hi, and welcome to 4.3 Independent Practice. We're talking about proportional relationships and their graphs. It's taken from this book here, the grade 7, or the accelerated. If you don't have it, link in the description for a copy of the book. All right, let's get going. So our first problem, we got several things here. We have for exercise 8 through 12, the graph shows the relationship between time and distance run by two horses. Okay, explain the meaning of the point 0, 0. Okay, well, what that means is we have 0, 0 is this point right here, and this is time, as we can see, and this is distance. So what that means is, let me get black going here. What that means is the distance. Oh boy. That's supposed to say distance. Let me write that nicely. Sorry. The distance, which is 0 miles, that each horse runs in 0 minutes. Yeah. The horse is not running anywhere. It's not going anywhere in 0 minutes. How long does it take each horse to run a mile? Well, for horse A, that is, let's see. Whew, 1 mile would be, let's zoom in here quite a bit. And we're talking 1 mile is, I'll put it in red right here. That's 1 mile. And we have to follow that here for A. That looks like it's 4 minutes for A right there. And it's like 2.5 minutes for B. So 4 minutes is, that would be 4 minutes. And for horse B, it'd be 2.5 minutes. Okay. Next. Multiple representations. Write an equation for the relationship between time and distance for each horse. Well, we could use what we have in the previous one for horse A. Well, now to figure that out, we need to know a couple things. I better step back here a little bit, and geez, maybe I better get here. So for A, so we need the K, the constant of proportionality, which is the y value over the x value. And let's go for A first, and then for B. K is the y value over the x value. So we need to figure out, first off, I see that this crosses the grid here. That's a nice spot. Yeah, I'm just kind of looking at, yeah, that's good. And then it crosses the grid also right here. Okay, so for horse A, we have the y value for this. So if we go to this dot here, the y value is 1 and the x value is 4. Remember, the y value is that vertical and the x value is the horizontal. So again, y value 1, x value 4. So the constant of proportionality is the y value is 1 and the x value is 4. And let's do B also since we're here. The y value is 2 and the x value is 5. So the y value is 2 and the x value is 5. So this is what we're going to use in our equations, 1/4 and 2/5. So for A, it's going to be here. Y is equal to 1/4 times x, and horse B is, that, if you remember, is 2/5. Y is equal to 2/5 times x. And that's what we got. Okay, so let's draw some conclusions. At the given rates, how far would each horse run in, oops, I'm trying to, each horse run in 12 minutes? Well, X is the amount of minutes. So horse A would be y is equal to 1/4 times x, which is going to be 12. Well, 1/4 times 12 is the same as 1/4 times 12 over 1, which is 12 over 4. Really, it's a fancy way of talking about, well, what's 12 divided by 4? And it's 3. So that would be 3 miles. And then horse B is y is equal to 2/5 times 12, which is 2/5 times 12 over 1, which is 24 over 5, which, you just 2 times 12 and 5 times 1. Let's see, 5 goes into 24 4 times with 4 left over. 4 and 4/5 miles. And yeah, so that's it. That's how long, that's how far they would go in 12 minutes. Okay, let's analyze our relationships. Draw a line on the graph representing a horse that runs faster than horses A and B. So let's draw that line. A horse that runs faster. Well, take a look at this real quick. Given the same amount of time, let's say given 4 minutes, this horse runs 1 mile, but this horse is running farther in the same amount of time. That means this horse is running faster. So to draw a line that goes of a horse that's going faster, you just draw something like this. Anything above line B. So you take line B, anything above that, that would be a horse. It'd be a really fast horse. But something like that is what they're looking for. Okay. Next. A bullet train can travel 170 miles per hour. Will a graph representing the distance in miles compared to time in hours show a proportional relationship? And that would be yes. I have a few things to say here, so let me just pause it for a moment. All right, so this is what I got. And I said, well, yeah, a graph of miles traveled compared to the number of hours will form a line that passes through the origin. Let me show you what that means. If I have this here and miles per hour, so miles, miles. So this would be miles, and this would be hours. So if the train can travel 170 miles per hour, so at 0 hour, let's say the train hasn't even started yet at 0 hours, how far is it going to go? Well, that train is going to go nowhere when it starts at 0 hours. After 1 hour, it traveled 170 miles. If after 2 hours, that would be double that. That'd be 340 hours. And everything in between. So at half the time, they go half the distance, and so on. You would have these dots like this. And if you connected these dots, it'd be a straight line through the origin. Next, number 14. In critical thinking, when would it be more useful to represent a proportional relationship with a graph rather than an equation? So this is what I got. When comparing two relationships, the comparison may be easier to see on a graph. Although, I don't know, if you have something like y equals 2x compared to y equals, oh, wait. I know what I'll do. I'll do this different color. Y equals 4x. And if I have this and this, y equals 2x, that means that the y value is twice the size of the x value. So if I have 1, this would be 1, this would be 2. Oh, wait, yellow dot, huh? And if I have 2, then 4. and I put another dot like that. And I would have a line that looks like this. Okay. Now, if I have y equals 4x, that means the y value, remember, this is the y, this is the x. The y value in this case is 4 times the size of any x value. So if you have 1, then you would have 4. If you have 2, then you would have to go up to 1, 2, 3, 4, 5, 6, 7, 8. And you'd have 2 and 8 like this. And if you go something like this, so you can, the point is you can visually see this one is taller than this one. Whereas, I don't know, I guess it's easier to look at it this way, but I can also see that 4 is bigger than 2. And so this is going to yield a larger y number than this one will. But that's what I'm getting at with this statement here. Okay, multiple representations. Bargain DVDs cost $5 each at Mega Movie. Mega Movie, graph the proportional relationship that gives the cost y in dollars of buying X bargain DVDs. Well, okay, think about this for a moment. If we have, this would be X. Oops. Let me make this a wee bit smaller. So if you have, if this were X and this were Y, so X would be DVDs and Y would be cost. So if you, it's $5 for each movie. So, so if you have one movie, that's $5. If it's 2 movies, it's twice that. It's $10. If it's 3 movies, it's $15. If it's 4 movies, it's 4 times 5, which is 20. Let's graph these points. 1, 5 would be like about there. 2, 10 is about here, something like that. 3, 15, 3, 15, something like there. And 4, 20. Ooh, 420, right there. Okay, so if I draw a line through it, there you go. And I just used, you know, some points on the table to make that. Okay, so there it is. And if I look down here, give an ordered pair on the graph and explain its meaning in the real world. Well, you can have 4 and 20 is pretty easy. So 420, 4 DVDs cost $20. There's the meaning of it. Let's look at the next one. Number 16. The graph over here. Bring it over. The graph shows a relationship between distance and time as Glenda swims. How far did Glenda swim in 4 seconds? We have 4 seconds right here. How far? It looks like 8 right there. Going straight up. 8 feet. So that's 8 feet. And we have communicate mathematical ideas. Is this a proportional relationship? Explain your reasoning. Yes. The graph is a straight line through the origin. Okay? Multiple representation. Write an equation that shows the relationship between time and distance. Use your equation to find how long it would take in minutes for Glenda to swim 1/2 mile at this rate. Okay, so we're going to write an equation that shows the relationship. Let's take a y value divided by the x value. So this is going to be easy. So to get our equation, we need the k, which is a y value divided by the x value. So I think that this is a pretty easy one. This is a y. Remember, this is the y, this is the x. So y value 2 over the x value 1, right? 1's going to go right there. I'll put 1 there. So that would be 2 over 1, which is 2. That is our k. That is critical because our equation is, so write an equation. So it's y equals, that was k, y equals kx, but we write the k, which we just found was 2. So it's y equals 2x. This is our equation right there. Now we're going to have to do a few things here. We have to figure out how far it takes for her to swim a half mile. Well, this right here, that y value is in feet, and it's usually miles per and then what? That's in feet, and this is in seconds. So that's kind of tough right there. So what we got to do is we got to figure out how long in minutes. See, they want us to find the minutes right there. Right there. Minutes. So we got to do a few things. I'm going to need some room for this one. Okay, we got a work area here. So 1/2 mile. How many feet is that? Well, 1 mile is equal to 5,280 feet. So a half mile has to be half that, which is, I think it's 2740. I'm just going to check with my calculator, because I kind of did that in my head. 5280 divided by 2. Oh, 2640. Yeah, good thing I checked that. So it's 2640. That makes sense. 2640 feet. So we have our y equals 2x. We know that y is how far she needs to travel, which is a half mile, which is 2,640 feet. And then she does that, and it's 2 times the number of seconds. We're going to have to change those seconds to minutes, but we'll do that all in due time. So let's solve for x, the number of seconds. We divide both sides by 2. They cancel, and we have 2640, 1320 is equal to x. That's the number of seconds. This is the number of seconds. So how many seconds are in a minute? There's 60. So we have to take this 1320 and divide by 60 to find the number of minutes. And that's so 1320 divided by 60 is 22. And that's it. Whew. So 22 minutes. Wow, that was a lot right there. Now let's get to the hot questions. Make a conjecture. If you know that a relationship is proportional and are given one ordered pair that is not 0, 0, how can you find another ordered pair? So this is it. Divide the second coordinate by the first to find the constant of proportionality, which is k. Substitute the value of k into the equation y equals kx, then choose a value for x and solve for y to find another ordered pair. How about I give you an example? Let me make this smaller, and I'm going to erase my work area here. And let's say you have this here. You know that it's proportional, and you're given at least one ordered pair. Like, let's give an ordered pair of 4, 1. Okay. Sorry, I want 1, 4. No, that's okay. 4, 1's fine. So if I have 4, 1, this is the x value, this is the y value, this is the x coordinate, this is axis, I should say, x-axis, y-axis. So divide the second coordinate by the first and find the constant of proportionality. So the second is 1 and the first is 4. So k, the constant of proportionality, is 1 over 4. Okay, substitute the value of k. Substitute the value of k into the equation. So if we have y equals kx, we're going to substitute right there. So y is equal to 1/4 times x. So we have our equation for this proportional relationship. Then you choose a value for x. I'll choose 12 because that sounds like it's going to be pretty easy. So if I have 12 for x, then what will y be? Well, I put 12 in for x. 1/4 times 12. I did this earlier, actually. 1/4 times 12 is 1/4 of 12, which is the same as 12 divided by 4, which is 3. So y would be 3. And there you go. There's you found the other ordered pair, right? To find another ordered pair. Full example. Okay, okay. The tables show the distance traveled by 3 cars. Let me erase this stuff over here. So, we have car 1, car 2, car 3. Which communicate some mathematical ideas. Which car is not traveling at a constant speed? Explain your reasoning. Well, this is 120 divided by 2. So that's 160. This is 160. Whoa. Wait. No, I'm sorry. It's 60, right? Yeah, it's 60. What am I thinking? 20 divided by 2 is 60. 180 divided by 2 is 60. And this is 60. And that is 60. So that's good. This is 40. Wait. Yeah, 40 times 5. And that's 40. That's 600 divided by 15 is 40. And 800 divided by 20 is 40. Okay. And this is 65. 85 divided by 2. 85 divided by 2 is 42.5. So it's this one. This one's not moving at a constant speed right there. So it's car 3. And how do I know? Cars 1 and 2 show they show a constant rate of change. But the rate of change for car 3 is not constant. Okay, and then we have, let's see, car 4 is traveling at twice the rate of speed as car 2. How will the table of values for car 4 compare to the table of values in car 2? So what I have to say about this is, if the values in the time column are the same, each value in the distance column for car 4 will be twice the corresponding value for car 2. Let me give you an example. If you have time distance, dist for distance. For the first one, so car 4 is traveling twice the speed. Then if you have one whatever unit of time, then the distance would be twice. Twice would be like 2. 2 would be 4, it'd be 3, it'd be 6, it'd be twice that distance. So compared to if time originally, so that would be that if it was moving twice. So that means the original would be time and distance. Oh, and so this would be car 4, and this would be car 2. This is kind of a messed up thing, but so if time would be 1 to 1, it'd be 2 to 2, there'd be 3 to 3, and so on. So basically, these values in car 4 would be twice the values of car 2, right? So double that, double the 2, double the 3, and so on. So that's what you got to know about this lesson. 4.3 on rates of change or proportional relationships and their graphs and so on. And that's it. Thanks for watching.